Hello everyone, and welcome to our video of finding the 6 trigonometric functions based on a point. Okay, so if we have a random point, it says the point 5, -12 is on the terminal side of an angle theta. Find the exact value of the 6 trigonometric functions of theta. All right, so notice this is not on the unit circle. That actual point, that's okay. We would still sketch it. So we have 5, which would be to the right, and then down 12. So we've got 1, 2, 3, 4, 5, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it's down there. Okay, however, these points still have the similar property. So that's an x-coordinate and y-coordinate of what we would want from the unit circle. However, the difference between this and the actual unit circle, let's kind of sketch out the full. So our unit circle has radius 1 on it. Okay, so that's the difference between what we currently are dealing with, and we would just say, well, if we knew what the x and y coordinates were, we would just take that as the cosine of it and this as the sine of it. So the x coordinate and the y coordinate were ready to go. However, that's when the radius is 1. On this problem, if we were to draw a circle through here, okay, so it's probably not the best circle. I'm doing it dashed. The radius of this circle would not be 1. Okay, so what we would need to do is just find that radius. Okay, so to find the radius, let's mark it. So we do have a right triangle to help us. That is the radius right there. We know that this length is 5, and now triangles, they can be tricky if you want to keep the sign or not. I'm going to do -12. Often with triangles, I don't do any signs, but since I'm looking at this in the quadrant, I'm thinking I want to use the sign for now, but it's kind of up to us. Either way, it's a right triangle, so that means we can use Pythagorean's theorem. So 5 squared plus the -12 squared would equal that r squared. 5 squared is 25. -12 squared is positive 144. Okay, so that's where you got to be careful with the negative too. Negative squared is a positive number. And then it simplifies to be 169 is r squared. When we square root both sides, again, plus minus for good habit, I'm going to choose the positive though, for a radius of a circle, and the square root of 169 is a nice number. It is 13. Okay, so we know the radius of this circle is 13. Okay, so the difference between, again, the unit circle and this circle is that their radii are different. However, looking back at the unit circle, so our x-coordinate, if we did divide that by the radius, 1, and divide the y by the radius 1, it doesn't change the answers to the cosine and sine. However, on this problem, we would want to. Okay, so over here, I've got this 0.5 and -12. Okay, so just making it extra bold. And all we're going to do is we're going to divide each of these by 13, so the radius, to help us along with the problem. Okay, so that's the little trick. So now we have something that would be equivalent to what would have happened with the unit circle. So now that we've done all that preliminary work, let's set up our sine of theta, cosine of theta, tangent of theta. Let's get these 3 and then to make sure I have enough space. So now I can say the sine of theta is this y coordinate. It is -12/13. I can say the cosine of theta is that x coordinate, 5/13. And then the tangent of theta, I could divide the y by the x. Okay, so the -12/13 divided by the 5/13. Now those 13s are just going to cancel. Okay, so those 13s cancel, and we're left with -12/5. Okay, so there's our 3 big ones. And then now that we have those 3, we can get the reciprocals. So we've got cosecant of theta, secant of theta, and then cotangent of theta. Okay, so cosecant of theta, just flip your sign of theta's answer, so negative 13 over 12. Secant of theta's answer is to flip cosine's answer, so 13 over 5. And then cotangent of theta is to flip tangent of theta's answer, which is negative 5/12. There we go. So there's all the three big ones. Okay, one other thing that you can do with this problem, double check the signs. Notice we are in quadrant 4, so let's mark that right there. So yeah, sine should be negative, cosine should be positive, tangent should be negative, so all of that information is looking good. The other thing we could have done, we could have gone back to our original definition of tangent. We know that tangent of theta is y over x. And so on this problem, it is the negative 12 over 5, which is what that simplified into anyway. But with tangent of theta equaling negative 12 over 5, we could have done a right triangle. We have opposite, we have adjacent, and then we could have used Pythagorean's theorem to get the hypotenuse, which would be 13 either way. And then we could use SOHCAHTOA on this to help us. Okay, so notice opposite and hypotenuse matches the sine answer, except we do have to make sure we're saying, hey, we are in quadrant 4, make sure to put the signs on it. Okay, so there's lots of nice ways to double check ourselves. So we could do unit circle, we could do SOHCAHTOA. Both of them will give us the same thing. Okay, so that's that. If you have questions, please let me know. One other reminder, so we do this when we have a point that's not on the unit circle. So if it's on the unit circle, you just kind of go immediate. It's ready to go. Okay, so this is just a little difference. Okay, so thanks for watching. If you have questions, please let me know.